We're going to begin next by talking about the chemistry of life. And we're really going to talk about this in terms of how it relates to life, not just chemistry. We're not going to do stoichiometry or any of the chemical equations, but we're going to talk about how that works in forming life and in making sure that life continues to be able to be formed here on our planet Earth. So what we're going to talk about in this section is describing what atoms are, their structure and how they bond together, understand water's features and the way that it supports all life. That's why I chose this water backdrop for our PowerPoint today. Describe carbohydrates, lipids, proteins, and their structure and their function, so how they are built up and what it is that allows them to do. And then describe nucleic acids and their structure and function. So the first thing that we're going to talk about today is atoms. And when you think of atoms, you may have this picture of something that you drew when you were in high school, this idea of the nucleus with the electrons swarming all around it. And this is actually nothing what an atom looks like, but it is a good representation of what an atom is. This nucleus that has the protons and the neutrons, and then the electrons swirling all around it. So everything out there, everything, the air that we're breathing, the land that we're standing on, our bodies is made up of atoms. And the atoms are most broken down to the smallest substance. An element is a substance that cannot be broken down chemically into any other substance. So if you look at your periodic table, an element is each one of those different spaces on the periodic table, and we'll look at that coming up in the next slide. So some examples of elements would be things like gold, things like carbon, things like copper. It's funny, you think about copper and you think about pennies, but copper is actually a fundamental part of our bodies. We need it in order to be able to survive. And an atom is a bit of matter that cannot be subdivided any further without losing its essential properties. If you were to take one gold atom and you were to break it apart, it would no longer be gold. And so all of gold together, those are an example of elements. And then we'll talk in the next slide about mixtures and compounds. So understanding, first of all, those little squares that make up the periodic table. And I'll show you, this is the periodic table. So just looking at one of those squares, which I think the first one that we're looking at is carbon, which is right there. Yep, carbon. Carbon, first of all, every periodic table is going to have certain keys or certain parts to it. So this number that's up here in the left-hand corner, that is the atomic number. That is the number of protons that are found in the atom's nucleus. Then we have the element, which is the big, usually single letter, sometimes two letters. That's the element symbol or an abbreviation of what its name is. Usually it's the first letter of whatever the name of the element is, but as we know, there's a lot more elements than there are letters, so sometimes we have two letters. The element's name is usually put on the abbreviation, and below it you can see that there is an atomic mass. That is the mass of both the atom's protons and the atom's neutrons. And so whenever you're thinking of the atomic number, that's just the simple number that's up there, and then what the entire nucleus is going to weigh, or the mass of the nucleus, is combined right there. And it's fit into that periodic table of elements. So an element's color code here in the periodic table here, you can see that they're grouped into certain colors, and that's based on the way that they interact with other elements. And so we have gases, we have here, oh, that's not my thing is chemistry, so I'm not going to even try and pretend like I know the names of all of them. But we have here some of the most important ones: hydrogen, carbon, nitrogen, and oxygen. Those are the big four, the ones that are really important for life. Also found in living organisms is sodium, phosphorus, sulfur, chlorine, potassium, and calcium. If we go forward, since I was talking about it, I'm going to talk about it. Let's see if I can get to it. Nope. There we go. The 25 elements that are found in your body, and then the big four. So your body is mostly composed of 4 elements. Those are oxygen, carbon, hydrogen, and nitrogen. And so the other 4% of your body, that makes up 96% of your body. And the other 4% is going to be things like calcium, phosphorus, potassium, sulfur, sodium, and chlorine. And then there's just trace amounts of some of the other minerals that are found within your body. But if you think about what this is mostly made up of, if you look at oxygen and hydrogen, so a lot of your body is made up of water. About 60% of your body is made up of water. Then carbon, that's usually the things that we get from our food, and nitrogen, which we get from the air that we're breathing all around us. So the 25 elements that are found in your body and the big 4.